When it comes to electrics aboard our boats, everything starts with the alternator. And if it's not powerful enough or configured to meet our needs, then whilst your floating palace may look wonderful, using it will be a complete nightmare. Never fear, Charles Sterling is on hand with everything you need to know.
Hi, my name is Charles Sterling from Sterling Power Products in Droitwich. Most people purchase boats because they look pretty, which is fine, that's their choice and they're capable of making those decisions. However, my job is to ensure that your pretty boat works, and that's the difficult part. Over the course of this series, we will break your electrical system down into 4 main categories. We'll start with the alternator, then we'll go to the battery size and types, then we'll go to how to charge them effectively, and finally we will show how to effectively use this power you have to satisfy your needs on board. There's a common myth that just because you have large alternators you can charge your batteries faster. I'm here to show you that that may not necessarily be the case. This is an alternator test bench used for obviously testing alternators. On the test bench at the moment we have a 90 amp Bosch alternator, and here we have a 200 amp alternator. Now as you can see, these two alternators are the same size, but obviously the question is, well, why is this one only producing 90 amps while this one is producing 200 amps? And the secret is in the revolutions of the alternator. Although they are the same size, this unit here will produce the power at a low RPM. This unit here will produce the power at a high RPM. For example, if you are a police car and you're at low RPM with your lights working, you would want an alternator like this. If you are a racing car and your engine's running at high speed all the time and you want extra power, you would want an alternator like this. Each of these alternators has a graph attached with it called a power curve. This shows the amount of amps that the alternator can produce against the revs of which the alternator turns. Now the huge mistake is when people take what they think is a high output alternator and put it into an application where the speeds are relatively low. The end result is this alternator, although it's 200 amps, is useless. Okay, the important aspect of all alternators is the power curve. Both these alternators, although they're the same size, have two different power curves. The 90 amp alternator has a much lower current here, with a 200 amp alternator will give you 200 amps but at a much higher revs on the alternator shaft. These graphs also show us the importance of the speed of your engine to the speed of the alternators. For example, if we have a poorly set up boat, we might only be cruising at 800 RPM and only getting access to 30 amps out of a 90 amp alternator, where if the boat configuration is set up correctly, we can be getting 80 or 90 amps out of the alternator at cruising speed. So the question is your alternator RPM correct for your cruising speed? The critical aspect in order to work out your alternator RPM is to work out the pulley ratio on your engine. That is the ratio of the size of the main drive pulley to the size of your alternator pulley. You can achieve this with a simple calculation. Simply divide the diameter of the engine pulley by the diameter of the alternator pulley, and you will end up with a pulley ratio. The information we were able to glean from the previous graph was that the 90 amp alternator here produced full power at 4000 RPM. Now our cruising speed on our canal boat is in the region of 1000 RPM. So in order to maximize the power from this alternator here, we need a pulley ratio of at least 4 to 1. Now if, however, your pulley ratio is only 2 to 1, you can see from the graph that this alternator will only produce about 35 amps at 2000 RPM, which makes your configuration pretty useless. It's very simple to do your own power curve for your specific boat. All you require is a clamp-on DC amp meter and your alternator plus a large load on your battery bank. First of all, we will clamp the clamp meter onto the output of the alternator. This is measuring the current which is actually being produced from the alternator at any specific time. The alternator's current is then going down into your domestic battery bank. In order to ensure that the alternator performs at its maximum capability, we ensure that we have put on a large load on the output from the battery bank. So in other words, the load is pulling the alternator down as low as possible. That way the alternator will respond and produce its maximum current. The graph consists of engine RPM along the bottom and the amount of amps being produced by your alternator at that RPM. We have here a 110 amp alternator, which we're now going to demonstrate that by increasing the RPM of the alternator, you can get more current from it. The alternator is now rotating at our lowest RPM on this test bench and is producing 52 amps. For your power curve, you need to find out what your engine takeover speed is and work out how many amps you are now manufacturing. Then simply increase the engine RPM in increments of 200 or 300 RPM and measure the amount of current that's being produced from the alternator. So simply by increasing the engine RPM, we're now up to 60 amps, 71, 80 amps, 90 amps, 98 amps, 102, 106, 112, 112. So you can increase your engine RPM and plot the current. Hopefully you will find that at your cruising speed you will have maximized your RPM performance.